Space, the final frontier. This is the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. Its mission to explore the solar system, to seek out new observations and data, to boldly go where no podcast has gone before. And now the host of the Observer's Notebook, Tim Robertson.
Hello and welcome to episode 159 of the Observer's Notebook podcast, the official podcast of the Association of Lunar and Planetary Observers. I'm Tim Robertson, the host of the podcast and also the coordinator of the training program within the ALPO. Thanks for downloading and listening. The ALPO collects and analyzes observations of various solar system bodies and associated phenomenon, and publishes detailed reports concerning these bodies in its quarterly publication, the Journal of the Association of Lunar and Planetary Observers. This podcast depends upon donations from you, our listeners, to keep it going. If you enjoy what you hear, please donate via Patreon. You can start by giving as little as $1 a month. If you feel even more generous, for $5, you receive early access to the podcast before it goes public. For a monthly donation of $10, you receive a copy of the Novice Observer's Handbook. And for $35 a month, you receive producer credits on the podcast. You can help us out by going to www.patreon.com/observersnotebook. And if you'd like to join the ALPO, membership is only $22 a year. For more information, find us on the internet at www.alpo-astronomy.org. And we're also on Facebook. Just search for ALPO Astronomy. And yes, this podcast also has a Facebook page as well. Just search for Observer's Notebook. And if you enjoy what you hear in the podcast, please subscribe. That way you'll never miss any episodes. And now, episode 159 with Carl Hergenrother, the Executive Director of the ALPO. Enjoy. All right, I'd like to welcome everybody back to this edition of the Observer's Notebook podcast. And with us today, we have the Executive Director of the ALPO, Carl Hergenrother. Welcome back to the podcast, Carl.
Thanks for having me, Tim.
Now, today we're gonna delve into the time machine a little bit. Let's talk about not only the ALPO but astronomy. Where it was like we're 75 years old as an organization. So where do you think astronomy was 75 years ago?
So yeah, the ALPO was founded in 1947, and it was primarily founded to promote the observation of the solar system, the moon, the planets. Not so much meteors, not so much comets yet, but kind of the resolved bodies of the solar system that you can see. And 1947 is kind of an interesting point in time, not only historically but scientifically. I mean, we're only 2 years removed from the end of World War II. Mm. Really, that's 2 years removed from, almost a 20-year period of, economic uncertainty and political conflict with World War II and the Great Depression. But also astronomy was kind of in a strange place in 1947, especially planetary astronomy. If you go really, really far back, you're talking, the Renaissance and even, the 15th, 16th, 17th century, it was planetary astronomy that was at the forefront of astronomy. People were discovering comets, and, Halley was figuring out their orbits and linking comets up. Oh, comets can return. 1800s saw people figure out that meteor showers were, they weren't a meteorological phenomenon. They were an astronomical phenomenon, and they were related to comets as well. But then something happened kind of in the middle of the 1800s. You first of all had the advent of photography. Mm-hmm. You had the advent of spectroscopy. And then as you entered the 20th century, the early 1900s, you started to see the first, at that time, large telescopes, like Mount Wilson had the 60-inch, the 100-inch. And all of a sudden, these faint fuzzies that people like Messier and Herschel cataloged all those years ago that no one really thought much of other than, well, they're not comets, they're not moving, but they're fuzzy. All of a sudden, with spectroscopy and photography and the large telescopes, you started to realize that these faint fuzzies were something interesting. They were galaxies, they were planetary nebula, they were star clusters. And so astronomy kind of moved away from being very planetary focused and more of, closer to what we have now in the modern times, more of a cosmology type study.
True.
And also, planetary wasn't helped by, you can kind of say, the Mars Canal crisis.
Crisis. Okay.
Where, with Schiaparelli and with Lowell pushing the whole idea that there were canals on Mars, which is something that people were seeing visually.
Mm-hmm.
And that these canals were they were artificial creations of a dying advanced civilization on a drying out planet. And of course, after many, many years, it was realized that, no, that's not what's going on Mars. And so in 1947, people looked at the Mars and the moon as not places where there were butterflies and advanced civilizations and all this stuff, but just dead worlds. And I think that really kind of hurt planetary. And so for the professional community, planetary was almost a neglected field.
Yeah, it's I'm in the middle of a series of podcasts right now where I'm talking to historic observatories, and a lot of them I'm talking to are really old.
Yeah.
I have a meeting on Friday with the Vatican Observatory.
Oh, nice.
And that's been around forever. So it's just like it's really, really interesting to talk to them about their history and where they started with their observing programs as well.
Oh, yeah. Yeah. And you go back early enough and they were all observing comets.
Mm-hmm.
They were all, involved in doing star catalogs. I want to say the Vatican Observatory is one of the places where they were using spectroscopy for the first time on stars themselves.
Yep.
To actually understand what stars were made of.
Yeah.
I mean, it's kind of amazing to think that only 150 years or so ago, we didn't actually know that stars were hydrogen and helium and a smattering of other things. Mm-hmm. We just knew that they were up there and they were hot.
Yeah. The evolution of this hobby and this field of study has really been amazing, even just, since I've been into it.
Yeah. So one of the things I've been doing recently, kind of as, in response to the 75th anniversary, is in our journal, which comes out quarterly,
mm-hmm.
I've been writing kind of look back pieces.
Yep.
Where I say, okay, what was published in the journal 75 years ago, 50 years ago, 25 years ago? And it's interesting that if you go back 75 years, 1947, I mean, the journal was the main product of the ALPO at the time. This is definitely a pre-email, pre-internet time, 1947. So all communications were through the mail. And so Walter Haas, our founder, who created the ALPO in 1947, created what was then the Strolling Astronomer. Mm-hmm. We still call it the Strolling Astronomer, but we also refer to it now as the Journal of the ALPO. And it was, maybe a dozen and a half pages. And it's kind of interesting, the things that he was kind of pushing folks towards observing, or the questions that they were trying to answer. For one, like, did the moon have an atmosphere or not?
Mm-hmm.
This was still something that wasn't completely settled at the time. People were, like, as they are today, seeing what we call lunar transient phenomenon,
right.
LTPs. You might see a flash on the moon. For a long time, people were thinking, well, this is just observers, not necessarily imagining things, but you see things, especially
right.
when you're pushing the edge of perception, kind of,
mm-hmm.
when you're looking through a telescope. We now know that, well, you can detect impacts on the moon as, meteoroids or small asteroids hit the moon. But it was kind of interesting. One of the things that Walter was pushing folks towards observing back in 1947, 1948 was looking for meteors on the moon. That if the moon had an atmosphere, the best way to detect that atmosphere would be to look for meteors burning up in that atmosphere. So during like the Perseids and the Geminids, actually it was probably, I think it was mainly the Perseids at the time, he was actually asking observers to look for the possibility of seeing meteors. And of course there were some quote unquote meteor detections, which
right.
probably weren't. As we know now, sometimes it's just birds, distant birds flying across the moon. Sometimes it's stuff in your eyeballs, as we get older.
Yes.
Now when I look up at the blue sky, it's like, oh boy, look at all that stuff now. But yeah, it's amazing just how much, and of course, 1947, we didn't have spacecraft yet. That was, people knew that was coming, especially after the war and all the R&D that happened in those war years. But it would be kind of amazing to think, in 1947, what would they have predicted for 2022, 2023? And would their predictions have been, maybe they wouldn't have predicted enough? Or would they have kind of predicted stuff that still is 75 or 200 years out in the future?
Very true. Yeah, I'm still waiting for my hoverboard from 1980s.
Yeah, no kidding. Yeah, Back to the Future.
Yep.
They keep saying, but they're not really hoverboards.
No, no.
My kid's always like, we want hoverboards. It's like, no, that's not really hoverboards. So, looking at planetary astronomy today, of course, the thing to remember with the ALPO and other groups is, we do this because it's fun.
Mm-hmm.
I mean, yes, there's always, there is that excitement that what you're doing is furthering science. That, when you're looking, through the eyepiece at a dust storm on Mars or a brand new comet or something like that, you might be the only person looking at it at that time. Or you might be one of 200 people, but you may be the only person writing down what you saw at that particular time. And so those observations will definitely help in the future. But when you start predicting what the state of the field will be in 75 years, this is just going to be a fun exercise because you can't, imagine going back to 2019 and predicting 2023.
Right.
Without having no idea about COVID or the war in Ukraine or high inflation or all the stuff that no one would have predicted.
Right.
But we definitely can, make some, try our hand at predicting a little bit of what's going on.
Okay.
And sometimes that's just kind of extrapolating trends. But we'll try to have fun with this, especially towards the end, where we try to make some kind of crazy predictions, which may or may not be out of the realm of possibility.
Okay. Sounds good.
So I don't know if you want to go first with maybe what your favorite prediction is. It doesn't have to be necessarily 75 years out, but just in the future.
Well, I did a podcast with Scott Roberts a few years back, and I asked him, where do you think amateur astronomy is going? He goes, no more eyepieces. Everything you put into your telescope will be a camera.
I can believe that.
And we're there now.
Yes.
We have these robotic telescopes, these little 50 millimeter lenses that are taking photographs of deep sky objects that are relatively easy, affordable.
Yes. And it's funny because so many people kind of, some of more the old school observers, myself included, kind of poo-poo them a little bit.
Me too.
But that may very well be the wave of the future.
Mm-hmm.
Just set it up on the backyard, on the table. You don't have to have a permanent observatory.
Nope.
You set it up, you say, you sync yourself, you figure out where you're pointing, and I want observations of X object. And it does it.
Mm-hmm. Yeah, and you do it with your cell phone.
Yes. Yeah.
So looking ahead, it's I don't know. I'd like to. That's tough because I'm old school. I'm still the eyepiece guy, but where this hobby will go, I think a lot of it has to do with imaging.
Oh, definitely, and it'll be streaming too.
Yeah,
I can see where most people just kind of stream what they're imaging. Here's live pictures of tonight, at least over here in the Western U.S. and a good chunk of Central and South America. We've got the occultation Mars, the moon occultating Mars.
Mm-hmm.
Just everyone's streaming it live.
Right.
I could definitely see that happening.
Yeah. And, and if you go back, just go back 25, 30 years ago, the whole Dobsonian craze.
Oh, yeah.
Of telescopes too. No one saw that. It was crazy. John Dobson revolutionized amateur astronomy, building these, large aperture reflectors that were easy to operate.
Oh, yeah. Just look at the, again, going back to the old ALPO journal, 75 years ago or whatever, you almost never see a telescope larger than about 6 or 8 inches.
Right.
Because back then, everyone was making their own telescopes.
Right.
So they were mostly reflectors, maybe some very small refractors, but it was just stuff you could make yourself, usually very long focal length. So there was kind of a limit to how big your telescope could be. And now, how many people actually make their own optics? I know people out there to do it, but the average person, myself included, average observer, just buys stuff. And it's not that expensive to get your hand on a large 12-inch or 16-inch Dobsonian that can track for you and it's go-to.
Right.
It's amazing.
Yeah, I'm sitting there busting my brain trying to come up with what I predict for the future, and it's difficult to do that for me. I don't know.
Yeah. So one of the things I kind of made a short list of the positives and the negatives going forward.
Okay.
And I'll probably start off with the negatives, just because that way we end on a positive note.
I like that.
But I mean, observing is becoming more and more difficult.
Right.
Being planetary, mostly planetary focused, looking at the planets, a lot of the problems that I'm going to bring up don't really affect observing, say, Jupiter or Saturn, because they're bright, they cut through the muck. I mean, some of the best images you'll ever see, or best observing you'll ever see of planets, is done at sea level through 95% humidity, completely gunky skies like Florida or the Philippines where Christopher Go is, and stuff like that.
That Damian Peach in Barbados.
Yeah, he goes to Barbados and observes,
I've been to Barbados. It's humid in Barbados.
Yeah. I mean, I'm a comet person. We need clear skies. I go to mountaintops and blah, blah, blah. But for a lot of planetary observing, you don't need that. But I mean, the biggest problem with astronomy, amateur astronomy in general, or backyard observing, is just light pollution. And it's not just the fact that, cities are getting brighter because they're getting larger and there's more lights. But I mean, even your neighbors, everyone's got security lights on that are on all hours of the night. I mean, just my house here, I live kind of on the outskirts of Tucson. And when I first moved here 10 years ago, it was great. My backyard was nice and dark. Now I got 3 neighbors with lights shining directly into my backyard.
Yep.
And that's just getting worse and worse with time as light pollution gets worse. We've also got light pollution from satellites in low Earth orbit. I used to do a lot of meteor observing, especially 10, 20 years ago. And then I kind of stopped for a couple of years. And then last year I observed my first meteor shower in probably about 3-4 years.
Oh, yeah?
And I was shocked by how many satellites there were, to the point where it was distracting. You're looking for moving objects, meteors, but at the same time, there's like 3 or 4 constant satellites moving. It actually was a distraction.
Yeah, and then you get the chain of Starlink satellites going overhead.
Oh, yeah. Yeah, and that's just going to get worse and worse and worse.
Yeah.
Because, they're talking about launching tens of thousands, and then there's tens of thousands of the Amazon one.
Right.
Kuiper, ironically named after one of the, the few people in the professional astronomical community in 1947 who was doing planetary science, Gerard Kuiper. But yeah, they got the Kuiper satellites are going to go up in OneWeb, and then the Chinese have their own stuff, and the Russians will have their own stuff. And then they'll all start colliding, and it's just... Is it going to look like Coruscant, if you know your Star Wars?
Yes.
Where it's just, constant... lanes of things moving around the planet, and you just won't even see the stars anymore. The nice thing is, for planetary observers, that's really not going to be that big of an issue.
Yeah.
Because you're looking at relatively speaking, even the moon is small in the sky, let alone Jupiter, Saturn, Venus, Mars. And so, yeah, every once in a while, a satellite might go through the field of view, but when you're taking, 10 millisecond exposures at 200 frames per second, it's okay to throw out a few. Another issue that's really been coming up is just climate change in general. Especially here in the Western US, I remember when Comet Neowise was big and bright that July. That was the year the monsoon just kind of didn't show up in Arizona. And there were fires everywhere. I mean, the mountains just to the north of me were on fire. All of California was on fire.
Yeah, we had a lot of fires that year.
And there was entire weeks where I couldn't observe, not because it was cloudy, but because it was smoky.
True.
And that's becoming more and more of a problem, let alone, the fact that there's more cirrus out there, especially with the increased air travel, producing a lot more cirrus. So there's not as many clear nights as there used to be. And then there's one thing I'm going to talk about here, which is part problem, part, I guess, negative and part positive, and that's big science. We do a lot of this stuff because we find it interesting and fun.
Right.
But we also want to contribute to science. And that gets a little harder when the professional surveys are doing so much work. Like, for example, just this past year, Don Mockholtz passed away.
Right.
And Don is one of the few surviving visual comet hunters that were around who discovered, say, a dozen comets or so. And discovering comets visually is, I'm not going to say it's completely gone, but the days where you could discover 3, 4, 5 visual comets a year are gone. Now it's maybe one opportunity per decade where a visual comet might still be discoverable if someone was willing to, devote the time for it.
Yeah, I don't think David Levy's actively looking anymore either. I think
I don't know. Yeah, and I mean
it was those two basically in the United States that
yes,
discovered them all. You know?
yeah, yeah. So you've got for a long time it was amateurs who were discovering supernova. You
Right,
don't have to go very far back where you had like Robert Evans,
right.
discovering supernova visually through a 12-inch or 16-inch telescope. And now supernova, they're like a dime a dozen. They discover dozens of them a night down to 20th, 22nd magnitude. Even asteroid discovery, while not something you did visually, but with CCDs in the 90s, I mean, geez, that was back in a time where you could still discover 14th magnitude asteroids, brand new asteroids. And now all the asteroid discoveries are about 20th magnitude or fainter and being done by the professional surveys. And with other surveys coming online, like Atlas completely covering the sky, or Vera Rubin, which will be covering the sky, I think, every couple of days. It'll cover the entire sky down to about 24th magnitude. NEO Surveyor, which is NASA's next big asteroid discovery telescope, which will be launched probably later half of this decade, which will basically, it's an infrared telescope. It'll discover most of the asteroids and comets out there. And all these surveys constantly covering the sky, it does make you wonder, is there a place for scientific contribution by the amateur? And as depressing as that may sound, it's not all negatives.
No.
There's some big positives in there. For one thing, I mean, when Vera Rubin's got its gigantic multimeter aperture, discovering stuff at 23rd, 24th magnitude, that also means it's not seeing anything brighter than about 16th, 17th magnitude, because those are saturated. So if you're talking brighter variable stars or brighter comets or asteroids, you still need smaller telescopes to do that. But the other great thing about these big science projects is that they're producing a lot of data. And a lot of that data does end up becoming publicly available. So you can go through that data. You can pick your favorite asteroid. You can pick your favorite comet, favorite variable star. Find new ones that people are missing. There's one amateur, in particular, Sam Dean. He's a real young guy. And he's kind of cornered the market recently on whenever a new asteroid or comet is discovered, he will go back through the publicly available data from Pan-STARRS, from Atlas, from the various surveys going back, 20, 30 years. It's all online, and he'll extend out their orbits by 10 years or so. And that's the difference between here's an object that's borderline lost, and here's an object with a perfect orbit, and now you can actually do orbital integrations, and you can observe it for the next 5 years. And those are the kind of things that you can do when you have access to these data archives.
And a lot of it is that through the citizen science projects, yes.
Yeah, definitely. Definitely. And as bad as light pollution is for, most of us live near cities, because that's where the work is. Light pollution is getting worse. So yes, it's a little harder to do observing from your backyard, but I mean, now with groups like iTelescopes, and before that, Sierra Stars and Light Buckets, and those groups, SkyGEMS Observatory. I mean, you can just log in and observe with a telescope located in Australia or Namibia or Spain.
Yeah, I'm a subscriber for the SLU telescope.
Right. So that's the Canary Islands, I think.
That's Canary. So yeah, I can log on any night and look at anything I want, basically, with that telescope, and it'll do whatever images I want. It's pretty amazing.
Yeah, it's amazing that and here you have access rather than spend what could be a hefty sum of money to have your own 20-inch telescope with a 4K CCD in your backyard.
Right. You
can just pay for time on one of these telescopes located at a much better site than most of our backyards.
That's exactly right. Yeah, I think I pay $100 a year for that thing.
Yeah,
it's amazing. I don't use it enough.
And those telescopes that are being becoming remotely available are becoming larger and larger. I mean, right now the largest ones are about 0.5, 0.6 meters. You're talking 20, 24 inch. But there are 1 meters out there.
Right.
And I know there are, like, in Great Britain, they have a 2-meter telescope, the Fawkes telescope, that a lot of the amateur groups have access to. And I can easily see a time where, iTelescopes or some equivalent group might start selling time on a 1 or 2 meter telescope. Not to mention, since we're talking about where will planetary astronomy be in 75 years, I would be willing to take the bet that in 75 years there will be a publicly accessible space telescope for amateurs to use.
Oh, I see that as well. I would not be surprised. I mean, I think the Planetary Society thought about doing that years ago. I think it was.
You see proposals every once in a while. But I can definitely, right now, so many small universities, not even small and large universities are launching their own CubeSats.
Mm-hmm.
Small sats and CubeSats. It's not out of the realm of possibility for someone to invest. It doesn't even have to be $1 million. It could be less than that. Just to throw a 6 or 8 inch telescope into orbit.
Mm-hmm.
Imagine just having an 8 inch telescope just to look at Jupiter
above the atmosphere.
Without the atmosphere to worry about.
Yeah.
That would be great.
It would be. Let's do it.
Yeah, no kidding.
Let's take that. Let's take that grant money we have from the ALPO.
That's the funny thing is that right now the ALPO doesn't have its own dedicated telescopes. Other organizations do, like the AABSL has its own dedicated telescopes.
Good point.
But is it possible that in 75 years we might be talking about ALPO Sat 1? ALPO Sat 2,
or just Earth-based remote observatory that the members can log on to and use,
or just that as well. Yeah, definitely, definitely.
And that's a good idea. Interesting. Yeah,
and go ahead.
No, go on.
Oh, and of course, observing remotely is one thing, but at the rate things are going, right now, a lot of our members observe the moon. They observe Mars and the other planets. But in 75 years, will their great grandkids be walking on the moon and Mars, vacationing on the moon and Mars? I can see in maybe not 75 years, but definitely in the next 100, 200 years, Mars will be the Las Vegas of the future. That's my prediction.
Okay.
That'll be where everyone goes to get married or to go, because it'll be a great location.
That's a destination wedding.
Yep. Everyone will be bringing home moon rocks. They probably wouldn't be allowed to. There'll be laws against it, but just like national parks, they'll smuggle them home. And everyone's like, I got this rock from the moon.
That's true. That would be an interesting time to live in.
We're getting to a point now where, we have a meteorites section and people are, categorizing meteorites. But we've had at least, I think it's 5 asteroids have been seen now inbound before they hit the atmosphere. And that's just going to increase. Plus, a lot of people have fireball cameras. I, in fact, have a fireball camera that I'm hosting for a few, actually for the Vatican Observatory at my house here.
Oh, my.
And it could get to a point where there will be so many cameras looking up at the sky that every meteorite dropping event will be cataloged. And you'll be able to go out and pick up the rock, within days of it falling. I know there's people, I'll just kind of, Tim Swindle, who's the former department head of the Lunar and Planetary Lab, University of Arizona, has a dream that I really understand and agree with of, will the day come where you can predict a fall and then go out there with your catcher's mitt and you can catch it?
I don't know if I'd want to be there for that. Depends how big it is.
Right.
Yeah. Wow. That's an interesting concept there. Now, what about optics? Where do you think the future of optics are going?
So for optics, I really don't know what's going to happen in 75 years. I'm not an optician, but I know just the short-term trends. One thing I have noticed on the professional side, and I can see this maybe starting to come over on the amateur side, is if you want to really detect low surface brightness features. Now, we're not talking planets. We're talking, comet tails and trails and stuff like that on the sky. And maybe this is more applicable to looking at galaxies and dust in the Milky Way and stuff like this. One way to do that is to have a whole bunch of small telescopes, each with its own camera. And then you co-add all those, what they call fisheye telescopes. In fact, there's a group, I want to say they're based in North Carolina, one of the universities there. They have a fisheye lens telescope. I want to say it's called Firefly. And they're able to detect, they've got a bunch of, I think it's relatively small. It's just Canon 400 millimeter lenses, I believe. And they've got like 20 or 30 of them on a mount, each with their own CCD. And they're taking pictures and they're detecting low surface brightness galaxies that you just can't see. Even with the old Palomar Sky Survey, even with the Sloan Digital Sky Survey, you just can't see that stuff. You can't get the contrast to actually pick these out from the background. But they're able to do it with really, really small aperture equipment, just lots of them. And so the key is you have a lot of images with a different, basically you're beating down the noise in the background by taking a whole bunch of images with relatively small wide field equipment. And then you co-add it all. And I can see that work, especially on the comet side. I'm seeing a lot of, like, the best pictures I'm seeing recently for comet observations are being made with the Celestron Raza Schmidt cameras.
Oh, yeah?
There's 8-inch, 11-inch, and 14-inch versions. And they're really fast. They're like f2. Of course, like any super fast optics, it's, you have to be almost borderline insane to want to work with optics that fast, because there's a lot of finagling and getting the tilt right and the spacing right and everything like that. But if you're willing to master that, I mean, the images that are being taken that are showing dust trails on almost every short period comet, basically the meteors that are being produced by these comets.
Right.
And I mean, I can see a setup where people just have a whole bunch of these, and you all of a sudden, rather than have a picture of a comet which is traditionally taken with, say, a 10-inch or 20-inch telescope in a small field of view, and going, okay, I can see a coma that's, quarter degree across, and here's a little tail that goes off the field. You'll see every short period comet might have a dust trail that goes 5-10 degrees. And I can see that kind of being a future for, just getting science out of your data. And again, that's kind of using optics in a different way.
Yeah. Now, what about adaptive optics for amateurs? Do you think there's a possibility of that?
Definitely. I mean, adaptive optics, I know there's always been these little tip tilt mirrors, but I think they only tip tilt in one, maybe two axes. For the professional telescopes, of course, they, especially the telescopes around here, Tucson, they've got pretty good adaptive optics.
Right.
The thing that's difficult there is that usually you have to have some stellar source that you can kind of map. In a lot of cases, they produce their own stellar source. They actually shoot a laser beam that ionizes the sodium layer that's about, up in the stratosphere there. And so they produce their own kind of synthetic 12th, 13th magnitude star that then they use as their guide. That's probably something the average person can't do. But who knows? In 75 years, we might all have personal nuclear reactors in our homes.
Oh, God, I hope not.
Yeah. But I can definitely see that being, where adaptive optics in some way. I mean, the computing power won't be the issue.
Right.
Especially if we ever have quantum computing. I almost wonder if, with quantum computing, what you won't see in the future is, instead of everyone working kind of by themselves, all the data collected by amateurs around the world all gets fed into a central, repository where it's then all combined. And so you're kind of almost you're getting images from everywhere, from slightly different angles, through different atmospheres and different observing conditions. And from there, by combining, observations taken by thousands of different people at, multiple hundreds frames per second, you end up with this super high resolution image. And I can definitely see that happening as well.
Yeah, that's interesting as well. Yeah. Wow. And the whole tracking system for telescopes. I mean, GPS was a major advantage now, because you could plop your telescope down anywhere in the world and it'll align itself to where it is on the globe. And basically, a lot of these mounts do everything for you now.
Yeah, and with things like astrometry.net, which figured out how to a nice quick algorithm where you just give a star field. You only have to tell it what the star field is, what your plate scale is, what the orientation is, and within seconds it figures out where you're pointed on the sky.
Yeah, the whole plate solving thing is fascinating to me. I mean, you could build a plate solving system for a couple $100 for a telescope. It's amazing.
Yeah, so it's pretty. I mean, to have a go-to mount now that just take a picture wherever. It goes, oh, that's where I'm pointed, and I'll point over here. I figured out my solution. I can figure out my tracking. I don't care how I'm mounted or what my orientation is. I'll figure out the tracking.
Yeah.
Yeah, I can definitely see that being. I mean, we're already seeing that. I mean, I think that's what the more. I forgot what the name of the Vespera.
Oh yeah, the Vespera. Yeah.
Yeah, that's kind of what they're doing.
Yep. That's all the robotic telescopes are doing that. That's the smaller ones and stuff. Yeah, it's crazy. I'm looking at those and just what they do. I don't know. I'm not a big fan of them, but I'll probably end up buying one of these days.
Oh, eventually, yeah. Yeah.
Give me a little bit bigger aperture and I'll be good.
Yeah, I mean, I just look at, the setup I have sometimes and I go, why do I have to figure this out every single night? It should be able to figure it out for itself now. The technology is definitely there. The algorithms are definitely there. The infrastructure is there. It's just getting it all to work.
Right. Every time. Yeah, that's the key. Okay. What else do you see in the future?
Oh, 75 years from now. So first of all, that's 2097, which is,
Thanks for that.
Almost the 22nd century. Almost the 22nd century there. I mean, just looking over the next 75 years, Halley's Comet will have come and gone again.
Oh my.
In fact, this year it's at aphelion.
Is it really?
I think it's December of this year. It's at its furthest point.
And they still see it, don't they?
It's been a while, actually.
Has it? Okay.
It has been a while. I don't know if there's any plans, say James Webb, to look for it.
Yeah.
I know James Webb definitely tried to observe, and I think they were successful at observing Hale-Bopp,
right?
Which will be of course, Hale-Bopp's a much larger nucleus. Be interesting to see if there's still any dust surrounding it. That'd be cool. But it's amazing when you think of something like James Webb. Here's a very large telescope. 75 years from now, will a James Webb-sized telescope be something that we can just get time on as amateurs?
Yeah.
Because the professionals will all have 40, 50, 100, 200 meter telescopes. So people might look at a 6-8 meter telescope and go, oh, that's small. I mean, just in my career, I started in professional astronomy in the early 90s. I remember back then a 4 meter telescope was large. Now a 4 meter telescope is considered small. It's not considered large anymore. I mean, it may not be considered small, but it's definitely not considered large. It's not an 8 meter. It's not a 10 meter. It's not combined like the VLT, which is combined, like 16 meters combined or whatever. 4 meter is not considered large anymore. So could we see a time where, a 4 meter telescope is on the Earth is a small telescope that amateurs can use? Just like an 8 meter telescope in space might be considered small because there's the next Arecibo is in some crater on the moon that's, 20 kilometers across or something like that.
Wow. Yeah, it makes my head hurt.
And then the things you can do with those telescopes.
Yeah.
I mean, you look at James Webb now, and one of the most exciting things about James Webb is that it's getting spectroscopy of individual exoplanets.
Yep.
It's figuring out what's in their atmospheres. I mean, if all of a sudden we've got, say, a few 2, 3, 4 meter space telescopes that are separated by, lunar orbit diameter, which is definitely possible in 75 years. Well, we as amateurs be taking resolved pictures of exoplanets. Oh, let's see what's going on in Alpha Centauri E.
Yeah.
Oh, look, they had a hurricane.
Look, they had a hurricane. Yeah, it's I like I mentioned earlier, the historic observatory series I'm doing. I ask all of them about their major projects, and every single one of them exoplanets.
Yeah.
That's the hot button right now for observatories.
I mean, in 75 years, will we have a spacecraft at an exoplanet? I mean, it is in the realm of possibility that you could, get something just using solar sail technology up to like 1/10 the speed of light.
Right.
So could we have something already flying through the Alpha Centauri system in 2097? I definitely think something will be on the way there by 2097. Maybe something will already have gone by.
Yeah.
I mean, it's definitely a possibility.
It'd be fascinating.
Yeah.
So let's look at the ALPO now.
Mm-hmm.
Executive director, what is your, give me the state of the ALPO today.
So the ALPO is doing well. We've got a number of active sections. We've got a large number of contributors. We got a journal that, thanks to the hard work of Ken Poshedley and Shawn Dilles, comes out every quarter. I mean, the ALPO has been going strong for 75 years. Though our membership is not as high as it was, but that's true of almost most amateur and even astronomical groups. The peak was kind of that space race time, 50s and 60s and 70s, and things have dropped off. But amateur astronomy itself, there's probably more amateur astronomers alive today than there's ever been in history. For one thing, there's more people alive, but also there's more people with access to the equipment that allow and the knowledge that allows you to enjoy astronomy as a pursuit and even contribute to astronomy, as a scientist. And so I definitely see the ALPO going strong for another 75 years. Again, mostly because the primary goal is because people who join the ALPO, and this is true of any amateur astronomy group, you join it because you have fun. You join it because you're interested in the subject. In our case, it's the solar system, how the solar system works, what's out there. But it's also, people kind of have a visceral connection with these objects. And even though, yes, there probably will come a time, like you said, where no one really looks through the eyepiece anymore. They'll probably just have it on your computer screen. But there is just something that feels really nice about just seeing a picture or having those photons hit your eye. And just going, Mars has been there for 4.5 billion years. The Earth has been there for 4.5 billion years. They were there long before we were here. They'll be here long after we're gone. But at this moment in time, it's like your connection with nature, of which the solar system is an extension of nature.
Yeah, I've been a planetary guy my entire life because I grew up in the San Fernando Valley, and there was a street light right across the street, and all I could see was bright objects of the moon and a couple bright planets, and I fell in love that way with it. And I still get, when I pull the telescope out and I look at Jupiter or Saturn, I still get that rush.
Right.
When I see those things visually, I still do, and I don't ever want to lose that. Even I'll look at the moon, and like when I did the training program, when I was in the training program in the 70s in the ALPO, one of the craters I studied was Eratosthenes, and I did probably 200 drawings of this thing. It's the first thing I look at when I look at the moon at night. If it's visible, it's the first thing. Is it still there? Does it still look the same? It's just so that the excitement I had then, I still have today, and that I think is the thing with observing the planets, and the moon. They're different every night.
Oh yeah,
comets. I mean, this crazy comet that's in the sky right now, it doesn't look the same on 2 consecutive nights.
Comet ZTF there.
Yep.
Yeah, every time I see a comet, I mean, especially a comet I'm seeing for the first time, it's kind of the sport of hunting it down. And when you see it, it's like, I gotcha.
Yep. Now I know what you look like.
Now I know what you look like.
Yeah. Very good.
Exactly. And it's the same way when I used to discover comets and asteroids. When that was part of my job. It was just, or even just getting light curves or something. Just, that kind of eureka moment of, I just saw something for the first time personally, or sometimes I just figured something out about this object for the first time ever that no one else knew, how fast it rotated. It's kind of cool.
Yeah.
I mean, in a way, through, over many large distances, but from your backyard, you're an explorer. You're a modern day explorer. Of course, it's much safer to explore from your backyard, but you never know what you're going to see. And most of the time it's kind of mundane, but every once in a while you see something that you weren't expecting, or see something that's brand new. And the only way we're going to realize that there's new stuff going on is just by looking up.
That's true. Yeah. And when I got into the ALPO years ago, I was looking for things to look for through the telescope. I'd seen all the planets and stuff like that, but I hadn't studied them. And this organization gave me the education through the training program and things like that. And just talking to other amateurs with the same interest, it gave me projects to do with my telescope.
Right.
And now I had a purpose when I was going out to not just to look, but now I had a purpose when I was observing, and that made it fun. Like you mentioned, it should be fun.
Yeah.
Very cool. All right, Carl, you got anything else you'd like to add?
I don't think so. It's almost 3/4 of an hour. Don't want to go too long.
No, we can go for 2 hours if you want. I'm retired now.
Congratulations, Tim.
Thank you. It's wonderful. Yeah, everything I thought it would be.
Yep, great.
All right, man. Well, it's good chatting with you about this.
Yeah, and then in 2097, we'll come back and do another podcast and see how our predictions held up.
I'll put it on my calendar.
Yep.
All right, that'll do it for this episode of the Observer's Notebook podcast. I again want to thank the executive director of the ALPO, Carl Hergenrother, for coming on today and letting us look back in time and also at his crystal ball into what he sees in the future. I hope you all enjoyed this conversation today. We upload new episodes of the Observer's Notebook on the 1st and 15th of every month. If you enjoy it, you can subscribe on YouTube. If you do, please rate and review it. We also are available on Apple Radio, iHeartRadio, SoundCloud, Spreaker, Google Play, Stitcher, Amazon, Echo, Spotify, and these podcasts are also available on our YouTube channel. You can help support the podcast by donating to it via Patreon, where you can give up to $35 podcasts, Steve Siedentop and Michael Moyer for their generous support. Thank you very much, gentlemen. The link for Patreon as well as the link for the ALPO is in the show notes. If you'd like to get a hold of me, my email address is cometman@cometman.net or on Twitter at observersnbpod. And until next time, I hope that you always have clear and steady skies. Thanks for listening.